Hi, I'm Song-So from Seoul National University. In this tutorial, I'm explaining how to deal with unsupervised domain adaptation tasks using domain-specific batch normalization. Unsupervised domain adaptation aims at how to transfer knowledge from source domains with a large number of annotated training examples to target domains which have unlabeled data only. One example is that we can easily obtain a large number of annotated samples in simulated environments, while it is much harder to get samples and labels in real-world environment. In this situation, the goal is how to train the model which also performs well in real-world scenarios. So there has been steady progress in this task. The most representative framework is Domain Adversarial Network. It has two branches. The first one is the classification branch, and the other one is the domain classification branch. So in this figure, one branch is trained to classify whether it is airplane or bicycle, and the other branch is trained to classify whether it belongs to simulated images or real-world images. But because the task is minimizing the domain divergence between source and target domains, so that the gradient of the second branch is reversed in the middle. While many approaches are adopted this kind of adversarial ways, we approached in a different point of view. We focus on batch normalization, which is indispensable in many deep neural networks, because batch normalization normalizes the mean and variance of batch distributions. We think this can be a proper component for domain alignment. So we propose a simple but effective idea which manually separates domain covariant information by adopting domain-specific batch normalization for each domain. So the idea is very simple. Just replace the existing batch normalization layer by domain-specific batch normalization layer. What it means is that the batch normalization layers are trained for each domain separately, while all the other layers, like as composition layers, are shared. And we found that just this replacement gives meaningful performance gain by capturing domain-specific information effectively. This is called stage 1. And after stage 1 training, we can obtain pseudo-labels on unlabeled target domain samples. So in the next stage, we adopt self-trained strategy using the pseudo-labels to further improve accuracy. Note that the self-trained strategy is only helpful with domain-specific batch normalization. And as a result, using DSBN, we improve performance by 15% point on the VISTA dataset. So to sum up, our DSBN layers can be plugged in any unsupervised meditation networks with BN layers, and also easily applied to multi-source or multi-target domain annotation task by adding more domain branches. And we are now investigating to extend this framework on domain generalization task. And we uploaded the tutorial codes on this repository. So as written in the README file, we can first install the environment and other dependencies and download the dataset on this website to the data folder like as this folder structure. And the train.sh file is the sample script, so that you can set other options like as batch size or model architecture and so on. And please refer to this mainer.py file for more details. You can check the other arguments and you can set other hyperparameters. And the key point of this tutorial is the dsbn.py file. In this file, this is the domain-specific batch normalization module, which takes both the feature and domain labels. So, and it has multiple normalization layers. So according to the domain label, Each sample is passed different batch margin layers, and using this module, you can easily apply it to other domain adaptation projects. Thanks for the listening.